Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on single phase full wave semi-converter, that is symmetrical. Now here, first here already we discussed single phase in the types of from single phase and three phase in the half wave control rectifier R load, L load, RL load, RL with freewheeling diode, RE and RLE load. So now here today we are going to have a discussion on full wave semi-controlled rectifier for symmetrical. So that we will that I am going to explain. So now here, so this is the diagram for single phase full wave semi converter. So now here it is a symmetrical. So how it is symmetrical I will explain. So this is a circuit diagram of single phase full wave semi converter. In this we are using two thyristors and two diodes. So now here in each leg only one diode. So one diode and one thyristor. So T1, T4, D4 and T3 and D2. So in the each leg, so one diode and one thyristor. So here the notation is here T1, D2 and next T3 and D4. So notation is cross T1, D2, T3, D4. So this is the diagram for single phase full wave semi-converter. Now here I am giving the AC supply and this is the supply. AC supply to this one. This is the load. Here one assumption is here load current is constant. I0 is constant. So I0 is constant here means here I0 is constant means here the load is highly inductive. The load may be RL or RLE load. Now here the operation here. So here Vs equals to Vm sin omega t. So now this is the here we are giving the supply to here. So now Vs equals to Vm sin omega t, that is VAB. So that is here VAB. VAB. That is VAB. So this is the VAB. Now here that is VAB. And now here Vs minus Vs means minus VBA, that equals to minus Vm sin omega t. So that is this is VBA or minus VAB. So Vs equals to Vm sin omega t, that is this is minus Vs equals to minus VBA, this is VAB and minus Vm sin omega t. Now here how it will operate first. So now here first T1 will trigger at alpha. So T1 will trigger at alpha during forward bias condition. So now here T1 will trigger at alpha. T1 and D2 will conduct during from alpha to pi. From alpha to pi. Alpha to pi duration, during alpha to pi duration, T1 and D2 will conduct. T1 and D2 will conduct. So the diagram will, it looks like this. This is the load. So now here the equivalent circuit I am drawing, T1 and D2 will conduct. So now here, so this is the AC supply. So this is T1 is conducting. T1 is conducting. And now here this is the load. This is the load. And here D2 will conduct. So now here T3 and D4 are open circuited. So now here why it is during forward bias condition, this is plus and minus. Here plus is connected to this anode and now here this negative is connected to this cathode of diode. This is a cathode. So now here T1 and D2 are conducting during duration, the alpha to pi duration T1 will conduct. So now here in this duration, this is the V naught, output voltage is V naught, so the supply voltage equals to V naught equals to Vs equals to Vm sin omega t, that is VAB, that is VAB. So now it will follow the supply voltage. So this duration, so it will follow the supply voltage. So T1, D2 will conduct from pi alpha to pi. So now here in this case, this is the IS. IS means this is supply voltage, supply current. IS equals to this load current is constant, always it is constant. Now here this supply current equals to this supply current means here during this period from supply current, this is the I naught current. So I naught current is this much amount, and now here from 0 to alpha, this value is 0, it is conducting up to this is I naught, this is I naught, from alpha to pi it will conduct. So now here this source current equals to this source current equals to load current I naught, output current. So now here from pi to pi plus alpha during this period. So from pi to pi plus alpha, what will happen? From this is alpha to pi, T1 and D2 will conduct from pi to pi plus alpha. So what is the how they will conduct? So now here T1 and D4 will conduct. So now here from T1 and D4 will conduct. So this is the load. So in this output voltage is 0. During this period output voltage is 0. Output voltage is 0. Now here what about the supply current? Supply current, this is I naught. Supply current equals to. So now in the previous case this is the load current I naught. So this current is I naught. And now here this is this duration from alpha to pi, this is I naught, and now here pi plus 2 pi plus alpha, this value is 0. So IS value is 0. So this IS value is 0. So now T1 and D4, here T1 and D4 from pi to pi plus alpha. So T1 and D4 will free will. D4 is freewheeling. Now here there is no output voltage. Now next case here from pi plus alpha to 2 pi, from pi plus alpha to 2 pi. So what is the here T1 and D2, and next here D2, T1 and D4 will conduct. After that here D4 and T3 will conduct. At this condition T3 will trigger. So here T1 will trigger. So now here pi to pi plus alpha, at pi plus alpha T3 will trigger. So now here this is the diagram. So now here in this case T3 and D4. So this is the T3. So now here how it will, this is the supply. So the equivalent circuit, this is T3 will trigger. This is the load voltage, and next T3 and D4 will conduct. So this is the D4 will conduct. So now this is the IS. This is IS and this is the load current I naught. So now here it is now here in this case Vs output current, output voltage equals to minus Vs. So this is a Vs, and here V naught, output voltage equals to minus Vs, means minus VAB, that equals to my VAB. So now here this minus VAB means this is VAB. So now here this is a VAB. So now this is VAB means here minus VAB means this is negative, here it is positive. Otherwise you can take this VBA. VBA means this is VBA and this is a VBA. So now here this VBA means you can take this one is also T3 and D4 will conduct. So now here during pi plus alpha 2. So this is pi plus alpha 2 to 2 pi. So this T3 and D4 will conduct. So now here this I naught current, so here this is I naught is constant, this is I naught, and this value is 0. And now here this source current equals to Is equals to minus I naught. So now here this is the minus I naught, source current equals to minus I naught. So now here again 2 pi plus alpha to 2 pi to 2 pi plus alpha. So this duration. So now here this duration, during this duration, so T3 and D2 will conduct. T3 and D2 will conduct. So now here during that period, so output voltage is 0, and output voltage is 0 means source current is 0. In that case T3 and D2 will free wheels. So now here from 0 to alpha T3 and D2, and next here at alpha T1 will trigger T1 and D2, and next from pi to pi plus alpha T1 and D4, and next pi plus alpha to 2 pi, so T4 and D4, and next T3 and D2. Now here what about the thyristor current and diode current? So now here thyristor current, here thyristor T1 thyristor is conducting up to T1 thyristor is conducting up to pi to pi plus alpha, pi to pi plus alpha. So the thyristor conduction angle is pi plus alpha minus alpha, that is pi. And next, what about the diode? So T1, same fashion for T3 also. So pi plus alpha to 2 pi plus alpha. Now the duration YT1 and YT3 same. And next here, what about the diode current? Diode is D2 current. So now here, if I see the D4 will conduct pi to up to 2 pi, pi to 2 pi. So means here pi to 2 pi means that duration is, so gamma of D equals to D4 is pi. So now here conduction angle. So now let us write all the equations. So first this is here, here. So now here this is the T1 D2, and next here T1 D4 will conduct, D4 will conduct, T1 D4 will conduct, and next T3 D4 will conduct, and next here T1 T3 D2 will conduct, T3 D2 will conduct. So now this is the output voltage, output current, and this is the this diagram we got here. And next here, what about this thyristor current? This is I naught minus I naught. And now here the diode current. So the diode current, this is for this is for D3. Sorry, this is for D4 current. So this is for T1 current. Same fashion for now. I will write the equations. Output current V naught equals to up to what duration it is conducting. So here the cycle is up to pi plus alpha. Here this is this duration up to pi 1 by pi. Now here this time period is pi, and now here from alpha to pi Vs sin omega t. So that equals to 1 by pi 1 plus cos alpha Vm. So output voltage equals to this value. Now here, what about the output current? Next conduction angle of gamma of T equals to T1 equals to gamma of T3 equals to here pi only. And next gamma of D3 and gamma of D2 is here D3 and D3 and D4, D2 and D4 is pi. So now here conduction time for thyristor and conduction time for diode is same. This is pi and this one is the pi. Because of this reason, so this converter is known as a symmetrical converter. Symmetrical converter. This is the first question, and this is second, and this one is the third. And next here, fourth one is the circuit turn-off time. So circuit turn-off time means the time for which the SCR is in reverse bias condition. This is the 2 pi up to what duration SCR is in reverse bias means. First I will take, so up to pi plus alpha it will conduct. So now here the omega Tc equals to 2 pi minus pi plus alpha, that equals to pi minus alpha. So Tc equals to pi minus alpha by omega. This is the circuit turn off time. Same fashion for that uh, T2 also, thyristor T3 also. Now here this is the first and second. Next here, what about the output currents? Output currents means here. So this is the output thyristor diode current, this one, and this is the diode current. So now here this is alpha pi plus alpha. So now here I naught equals, this is I naught. So now here source RMS source IT average value is equals to IT RMS value equals to. So now here the diode is conducting up to. So this is I naught. So this is the I naught. This is I naught. And now here I naught equals up to what angle it is conducting. This is pi duration it will conduct. So pi by 2 pi, that equals to I naught by 2. So now here same fashion, I naught by I naught into, so now here pi by 2 pi, that equals to I naught by root 2. So this is the fifth one and sixth one. And next here seventh one is here IT the average diode RMS current equals same I naught. So it is also conducting gamma of T equals to pi and gamma of D equals to pi. So now here it is also same, average value equals to pi by 2 pi, that equals to I naught by 2. And next eighth one is the ID of average equals to I naught square root of pi by 2 pi, that equals to I naught by root 2. So now here first one is a V naught equals to Vm by pi. So now here 1 plus cos alpha. And next here this is second question is here, this is second conduction angle. And next third one is a gamma of D equals to thyristor is pi. So first question average value of output voltage, this one up to this duration. And next conduction time for diode and conduction time for SCR thyristors, so that is pi. So same duration they are conducting means that is symmetrical. So now here this is pi duration and this one is a pi duration. And next here fourth one is a omega Tc equals to, that means circuit turn off time means pi minus alpha by omega. And next fifth one is the IT RMS value. So this is source current and this is the source current waveform. I naught. IT average value equals to I naught by 2 and IT RMS equals to I naught by root 2 and ID average equals to I naught by 2. And eighth one is the diode current equals to diode current RMS value. Sorry, this one is the RMS current equals to I naught square root pi by 2 pi, that is Im by root 2. I hope all these formulas are most important. 1, 2, 3, 4, 5, 6, 7, 8. So these are the waveforms. So VAB, VBA. So this is VAB and VAB. So this is T1 at alpha T1 will trigger at pi plus alpha T3 will trigger, and here T1 and D2 will conduct, here T1 and D4 will conduct. So T1 duration is up to pi alpha to pi plus alpha. And next here D4 and D4 and here this is T3 and D4. T3 and D4 will conduct. So D4 will conduct from pi to 2 pi. So now here again T3 and D2 will conduct. So T3 and D4 will conduct. This is the output voltage is constant because it is a highly inductive load. So now here during alpha to pi, so this current is positive, but here pi to pi plus alpha, this value is 0, and next pi plus alpha to 2 pi, so that value is negative. Next pi 2 pi to 2 pi plus alpha, that value is 0. So now here this is a thyristor current, this one is a diode current. So now these are the formulas. I hope all these formulas are clear to you. These concepts are clear to you. Thank you. Thank you very much to you.
Like, share and subscribe. Hit the bell icon for more updates.